Good morning, guys. So in this video, we will start solving some problems. I want you only guys to remember that the main objective of this chapter is to find the unknowns. These unknowns could be reactions, and they could be also some additional forces in the problem. So guys, basically you should know that in 2D case, I only have three equations, sum of fx, sum of fy, and sum of moments, which means I can only solve three unknowns. Okay, so guys, basically I want you to remember that the steps is to first draw the free body diagram. So this is the first step. It is to draw the free body diagram in order to show all the external forces, and the second step is to solve my equations. And don't forget guys that if I have a fixed separate, and this is the symbol of the fixed separate, like the case that we have solved in the previous video, then guys, I will have three reactions: vertical, horizontal, and moment. And I can assume any direction for the moment or for the reactions, and then I can know if this direction is correct from the answer. If I have a pin, and this is the symbol of the pin, or you can have this symbol here, so it is rotated, so this is a rotated triangle. Okay, it is the same, and here you will also have two reactions. One is vertical and the second one is horizontal. So even if you have like the example that we will be solving now, even if you have this one, then you will also have two reactions. Okay, one is horizontal and one is vertical. And finally, if you have a roller, then you will only have one reaction, which is vertical. And guys, pay attention. If the roller is oblique, then you will have one reaction that is perpendicular to the separate. And now if the pin is also oblique, like this case here, you will have two reactions. One is perpendicular to the separate and one is parallel to it. Okay, so the reactions should be perpendicular. Now in this case, guys, when you want to apply the sum of fx and the sum of fy is equal to 0, you can take another direction of your axis as long as they are perpendicular. So it is not mandatory, guys, to take x horizontal and y is vertical. So in this case, guys, if you think that if you take this axis as your y and this axis of this as your x, you can, if this will facilitate your solution. So you can take the directions of your references as you want for x and y, as long as they are perpendicular. So you cannot take x here and another axis that is doing an angle of 30 degrees. You should take them perpendicular. So you can, guys, rotate also x and y, and this is very important note that you can use to facilitate your solution. So here, if you pay attention to this problem here, so here guys, I have a rocker, which is the same case as the roller. Okay, so I will have a reaction, one reaction that is perpendicular to the separate here. So you can solve it by yourself. And now let's start by the first problem. Okay, so guys, this is the first problem in this chapter, and I will be solving this problem using the steps that we have discussed in the previous video. So basically, guys, if I take a look on this problem here, I have a beam supported by a pin at A. So guys, my advice for you is to memorize all the symbols of separates, because this will help you in putting the reactions. So since here I have a pin, this means that I have two reactions and they are unknown here. I have at B and E the same rope, okay? So this same rope around this pulley means that I have the same what? The same tension in magnitude, and this tension is also unknown. And I have at C a weight hanged, and this weight is known and it is equal to 80 kilograms. So basically, guys, I have three unknowns.
And they are the reactions at the pin, because I know, guys, that for a pin I have two reactions. The first one is the vertical reaction and the second one is the horizontal reaction. I don't have a moment here because in fact this is not a fixed separate. So I have two unknowns at A and I have the tension at B and E, and I should solve for them using the steps. But I want you guys to know that since I only have three equations, sum of x, sum of fy, sum of moments, this means that I only have three unknowns to be solved. So I cannot solve for four unknowns. Basically, guys, if I have a fixed separate here, okay, so guys, if I have a fixed separate here, can I solve the unknowns of this problem? Basically, if I have a fixed separate, this means that I will have three reactions. Vertical, horizontal, and a moment reaction, plus the tension at B and E, which means I have four unknowns, and this is a 2D case that has only three equations, sum of x, sum of fy, sum of moments, so I cannot solve for four unknowns. So guys, if I have a fixed separate, the question must give me the tension at B and E to find the reactions, and we'll talk about this later on. Okay, so here, guys, I have three unknowns. The first step is to draw what? So step one is to draw the free body diagram. Now, guys, you should be careful in choosing the free body diagram. So, of course, guys, here I will choose AC as my free body diagram because, in fact, I need to find the tension. If I take AC with this pulley, the tension will be internal, and this means that I cannot find it. Okay, so I will take AC as my free body diagram. So this is my beam, this is my free body diagram, AC. And then what are the external forces exerted on this beam? I have a vertical force here, a Y, a horizontal force here, a X. And of course, guys, these two reactions, okay, the direction of these two reactions could be not correct. So this depends on my answers. Okay, if they are positive, this means that my reactions are correct and vice versa. Okay, and so I have two reactions at A. I have the same tension T at B and E. However, guys, this E is oblique, and I think I know here the height and the base, or I know any angle, we will see. Okay, so I have a tension here, and I have a weight here that is equal to 80 kilograms. So let me, guys, see the given in order to know what are the inputs for the tension at E. Okay, so this is also given because if I don't know these values or the angle, this will be an additional unknown and I cannot solve the problem. So I should know here either the angle or these heights or these scales. Okay, so guys, I have two tension, one at B and one at E, and they are equal. Okay, and I have a weight that is equal to 80 kilograms times 9.81. Okay, so this will be step number one. Guys, I want you to be careful because in fact, if I don't know the point of location for each force and the distance from a point or a reference, like this case here, I cannot solve for this problem because these distances here are very important in finding the moment. Okay, so let's start. This is my first step, and now I will continue my step 2. So my step 2 is basically what? It is basically to solve the three equations. Sum of fx is equal to 0, sum of fy is equal to 0, and the sum of moments is equal to 0. So here, guys, I have three equations with three unknowns. So what you can do, guys, to write all these equations, to take your calculator and to solve them simultaneously. Or you can use the smart method to get rid from some unknowns and to solve them by hand by starting with the convenient equation like we will do now. Okay, so guys, basically, what is the first equation? Sum of x is equal to 0. Do I have forces in x direction other than ax, of course? Yes, I have the projection of t on x, and I know, guys, that the projection of t on x is t times 3 over 5. Okay, so basically, guys, this will be in the negative direction, ax will be in the positive direction, so ax minus 3 over 5 t is equal to 0. And this will be my first equation. I cannot solve this equation right now because I have two unknowns. So let's continue by sum of fy is equal to 0. So sum of fy is equal to 0 will give me what? Ay in the positive direction plus t times 4 over 5 minus what? Minus 80. Now guys, you can convert this to a force, so you should multiply it by 9.81, or you can keep it in kilograms and then your answer of the forces will be in kilograms and then you can convert it to Newton. So I will convert it to Newton, so 80 times 9.81, I put it after the equal sign because it is basically negative before this equal sign. So this is the equation of AY. Basically AY guys could be negative and or positive. So I'm not sure until finding t. So guys, this equation also could not be solved right now because it has two unknowns, AY and t. Now guys, what about the third equation, which is the sum of moments? What do you think? I should find the sum of moments. I can find sum of moments on any point on this beam and it should be equal to 0. However guys, I can find a point where the sum of moments is equal to 0 equation can give me the first unknown. What is this point? It is basically point A, because in fact at A I have two reactions, and if I take the sum of moment at A, these two reactions will vanish because in fact they are passing through A. So basically guys, you should behave in a very smart way by taking the sum of moments at the point of intersection of one or more reactions or unknowns. Okay, so this is what I will do now. Sum of moments around A. So what are the sum of moments around A here? Basically guys, sum of moments around A is equal to 0. I shall assume a positive direction. I will assume that the counterclockwise is positive, and let's start. Okay, so basically AX and AY will have a 0 moment around A, and then T will have a positive moment because it is doing a counterclockwise rotation, so it is plus T times the distance AB, which is 2. And then for T guys, I can have two components. The first one is in X, it is passing through A, so it has 0 moment. And the second one, which is Ty, or you can apply the second method, okay, and Ty times X minus Tx times Y, so it will give you the same answer. So here Ty is doing a counterclockwise, so plus Ty, which is T times 4 over 5, times what? Times the distance from A to E, which is 4, so times 4. And finally guys, I have the weight 80 times 9.81, and this weight is doing a clockwise, so minus, or I can say it is equal to 80 times 9.81 times what? Times the distance from A to C, which is 5.5. So this is my third equation. Take a look at it. So you can see guys that this third equation has only one unknown, which is T. So I can find T. Now here guys, T is positive, which means that the direction chosen for T is correct. Basically, I can predict this because in fact, these two ropes are holding this beam, so they are doing an external force upward, in the upward direction. And then guys, when I know T, I can substitute this T in the first equation to find AX. So AX will be equal to 497 Newton, and it is positive, which means that AX direction is in the positive X direction. Finally, I can substitute this T here in AY in order to know what is AY. Minus 707 Newton. Which means what? This means guys that AY should be downward. It is not upward, it is downward. Which means guys that this pin is doing a downward force on this beam. And this to overcome the tension at B and A. So basically guys, here the pin is doing a downward force to keep this beam in equilibrium. Thank you.